Hey, looky there. So, yeah, that's the title. So a little bit about me. I think I know about half the people in this room, but some of you I don't. I work at PayPal. You may have seen PayPal evangelists at different hack events and hackathon type events. I don't really work with that group. I'm actually with PayPal's platform engineering group. So I actually work with the engineering team across all of PayPal, which is sort of a rare privilege to get to work with all the lead devs from across engineering to help craft good APIs. That's my sole purpose there, along with the rest of my team. So we run what we call PPaaS, which is kind of a weird name, but PayPal is a service, so platform is our life. That's all we do all day long. I don't actually build anything. I just help other people build stuff and get it onto the platform and kind of provide the plumbing for it. So, obviously there's some sort of governance aspect to this, so what I call the G word, but we're really more of, I look at it as kind of a design consultancy and kind of a product add-on for most of these development teams. And as part of that, I get a lot of feedback as sort of an internal evangelist within engineering, so I get the opportunity to play stakeholder for a lot of other teams within our platform development group, so I'm stakeholder on a whole bunch of different teams. And as part of that, I'm obviously teaching a lot and kind of trying to explain to people what good looks like. So this is sort of a vignette of what we're doing as a platform. I'm kind of a startup guy in my background, so I'm always thinking, what can I learn from this? And if I had to do it all from scratch, what would be the things that I would take away that I would start doing from the beginning? And hopefully I can share that with you guys and maybe help out what you guys are working on with a little bit about how we run the program. I saw a monolith on somebody else's thing, and I was a little jealous because it was a better monolith, but we all start here, right? We've all worked in small, well, maybe you haven't worked in a startup, but if you have, everybody starts with a monolithic app. But as you grow bigger, the game becomes, how do we create bounded contexts? How do we start breaking things down into components within the architecture? This obviously allows us to scale things individually, so we can go really big for something like payments where we have huge volume, and maybe not so big in other areas where we don't get so much traffic. This obviously leads to a lot of team autonomy because each team can kind of do things their own way. So we have a wide variety of languages. We have Node teams. We have obviously a lot of Java teams. We've got little pockets of Python here and there. I think we even had some stuff in Go briefly. So the hard part about this, you got this big ecosystem of lots of services running around. How do you tie them all together? It becomes kind of a discoverability problem. Keeping a cohesive sense of platform is the tricky part. So that leads us to really look at the whole thing as a portfolio of APIs. That's how we refer to it. That's how we operate. We basically manage the portfolio for PayPal. The thing that fascinates me and keeps me motivated at a place that obviously is big and it's hard to do something this big. How many of you read the ThoughtWorks Technology Radar every year? Anyone? Yeah, you should. It's a really great source for trending technology. They keep track, and I want to say they do this quarterly. They get together their brightest guys, and they're very bright, to sort of define these spheres of where technology is moving. And I've been following this one for a little while, honestly scratching my head a little bit, the inverse Conway maneuver. And it's starting to get close to adopt now. It's the little triangle here because it's moving in. And the idea, I apologize if I'm clearing my throat all the time, the Stockholm allergies are killing me for some reason. So inverse Conway's law, everybody familiar with Conway's law? Computer science kind of concept? When you build software, it kind of tends to look like your organizations or look like your company. It sort of looks like your organizations or your underlying systems. The idea here is we're going to flip that on its head. We don't really want the APIs to look like the systems that they're built on. We want the APIs to look like the product that our customers see. So this is kind of a perspective that pervades everything we do. And to me, it's a fascinating experiment to see if what that does at something at this scale. So the first thing to realize is that when you look at a portfolio of APIs, especially a really big one, our platform's internal, partner, external, everything that we build, is that there's really two key perspectives. One is there's business, and the other is developers. And it's important because developers are the guys that are using these APIs they're implementing, but quite often it's business who decides what they want to use. So we have to kind of speak in different languages. So for us, we refer to the kind of business side of this as capabilities. That's all the business cares about. What are you going to make me capable of doing if I use your API? And of course, within that, there's some kind of categorization and packaging kind of concepts of breaking that down into some subcategories, essentially. And for developers, they don't necessarily care about that. They're really going to look at that URI as a sentence. They're going to read this combination of, namespace. I hate to borrow the SOAP phrase, but that's kind of what we call it. So like in our imaginary widgets API in the factory, you'd have factory as your namespace. It's not really a resource, it's just a categorization. This speaks a language to developers that's very different from the language that we would refer to in capabilities. There are cases, and I don't know how honestly common it is. It's probably pretty common, but not all the time, that we refer to things pretty much the same way here as we do at the sort of business language level, but not always. You can't make that assumption. So it's important to segregate those two concepts from the beginning. So from the beginning, we actually work on the capability level. We don't actually look at resources first. It's kind of strange, but we really want to know, what are you trying to accomplish? What's the goal? What is it that you're going to provide in terms of business value in this API that you build? And study that capability first, name that capability first, and then work down to resources. So as part of that, the capability is going to start showing up on our developer portal as a planned API. And so we immediately start getting discoverability for other teams to recognize things that are getting built. What they're going to be named is very important, that we maintain that customer perspective. Again, with this inverse Conway's theory, that we're going to name things based on the way that we want customers to see it, even internally. So even though we may have some system internally that everybody knows the name of it, we don't show that in the APIs anywhere. And I would just say, use a lot of caution with product names in your APIs. Product people are fickle, and they like to rename things. So it's tricky. It's a tricky balance. Sometimes your core product that you're actually providing is your capability. It is your resource. But sometimes if you got a really kind of kitschy name going on, you want to be careful about keeping it to truly the capability and not the name of the product. So I would say we do like a design first methodology, but it's right after portfolio. So we kind of have product, or what we call portfolio managers in the team, that do that initial phase. Then my team comes into play to actually do the kind of design work with teams to make sure that we're doing things right. It's expensive to go build stuff, and I think this is a recurring theme across the conference here, that design first is starting to kind of finally take hold. And I know there are certainly a number of resistors out there who want to build it and spit out specs, but it's a lot cheaper to invest in specs first and iterate on it. I think this is an area that we're going to work on a lot soon, is this notion of mocking APIs, but I'm a huge fan. The only real measure of usability is writing code against it. And you can't write code against an imaginary API that's sketched down in somebody's notes. You really need something that you can call and get data back on. So spec it out, pick whatever spec format you like. They're all a little different. They all have their ups and downs. They all have a little bit different intent to them. Pick something and mock against it. The important thing to realize, and I actually captured this from my last gig at UShip, it's a shipping marketplace. We were developing mobile apps in combination with the APIs, and we kept doing this: build the APIs, build a mobile app, release. And there's these painful little feedback cycles that happen when you're doing that kind of thing, right? And everybody starts saying APIs are bad because we build it and then it's not quite right, and then we have to go back and fix it, and it slows down the mobile release. So I like to say, let's parallelize. And that's the whole point of the mocking experience, is we want to race together. We want to spec up front, go off and build both sides of it. We'll build the API, we'll build the front ends, and we'll get there. We're not going to pass the baton at the end of the API development process. So I highly recommend the approach, and I'd say it's something we didn't do that great this year, but it's something we're going to work on really hard next year. So I'm always trying to sort of explain and measure what kind of value that we're bringing to the party by slowing everybody down with this design process, because it does, right? It takes a little longer. Our job is to be the client advocate. We're always I'm looking at every API design and thinking in my head, and sometimes coding on what's the code going to look like on a client for this. And so what's important about that, and this is important within your organizations, is put somebody in charge of looking at APIs. That may not be their full-time job, but put somebody looking at APIs that is not responsible for their delivery. And the reason that's important is if you have skin in the game on how it's implemented, it's going to color and influence how you design the interface. So it's important to segregate those roles. And I like to say that I'm in a position that I make server guys' jobs hard, and sometimes they don't like it. But that's the client advocate's job. If I can make the server do a little more heavy lifting and all those clients a little bit lighter, then I've done my job and I've added value for all those clients. I've reduced the dryness of all that code, right? Or I've improved the dryness. So what I like to say, and anybody that works with me knows the phrase, and now they say it to me when they're about to bring something up about implementation details, is I like to say, let's not take a tour in the hot dog factory, people, right? When we're designing APIs, you're not allowed to tell me how you're going to build it. I don't really want to know unless there's some horrible constraint that you just can't change right now and we have to release. Otherwise, nobody wants to see how hot dogs are made, right? I don't want to know how your API gets built. I just want to know what the interface looks like, and that's how we're going to discuss it. So there's been a lot of little discussions about versioning, and I absolutely agree you have to bake versioning in some fashion, and I really won't debate my favorite aspect, but bake it in. But the first rule of API versioning, in my opinion, is try not to. Really try to think long-term. Think about longevity in your design, because once you put it out there, it's going to be there for a long time. I mean, I'll tell you a little secret. PayPal's never turned off any APIs in like 10 years. So it's hard to get rid of stuff, especially when it's making you money. So there's sort of this fallacy that we can build extensible designs, and it's totally not true. Extensibility, if you really look at it, means you're building something modular and componentized that you can change and grow. And that's not what we do with APIs. We kind of build concrete things that people are going to rely on. So if anything, we can extend, which is different from extensible, right? We can add to it. We can do backward compatible changes, that sort of thing. But we have to be very, very cautious to never expose that implementation detail, because today's implementations, tomorrow's scrap heap, right? Stuff I built 2 or 3 years ago has been junked and thrown away. So the other aspect is when we look at teams that say, I've got a backward compatible change, I'm really worried, I know you say you don't want V2, what are we going to do? When we review those use cases and we say what requirements changed, quite often it's a different resource by the time we've completely changed its intent. So maybe it's a different URL entirely. So we do quite a bit of that. Or it maybe belongs in a different namespace or different capability. And so we can actually stand 2 things up at once, put one on a deprecation plan, and kill it. But so far, everything in the entire PayPal platform is V1. And I mean, that won't last forever, but that's the idea, is let's build a cohesive V1 platform and do our best to keep it in place. Obviously, most people in this room understand that nouns matter a lot in what we're doing with resource-oriented design. But there is a reality that there are things that fall into an RPC pattern, and that's okay, but we've got to test it every time. Every RPC design gets tested heavily. Terminology, so nouns matter in the sense that you're building noun-oriented resource collections, but it also matters in the words that you use. You get sort of obsessed with words when you do this stuff all the time. And I think there's a trend of linguists getting involved in API design for that reason. So vague terms like metadata and context, this stuff pops up all day long everywhere. Everybody wants a metadata. Everybody wants a context. What the hell does that mean? It could mean 1,000 things. So vague terms are really dangerous, because as soon as one person uses it, you have to have a definition that everybody agrees on for the whole platform. Well, the platform is big as we're running with hundreds of APIs. Good luck. So avoiding that vague stuff is really important. If you have industry terminology you can rely on, great. Otherwise, find something meaningful. Make sure it's in the dictionary if you can. Find meaning in your nouns. The other important piece, and again, an area that I really wanted to work on a lot better, is flow. So quite often, accomplishing your goal, so we're always looking at an API proposal, something that we're looking at building, as being a way to reach a goal, to get that capability completed. Sometimes one call doesn't do it. You have to do a series. I mean, if you look at PayPal's checkout process, you have to go create the payment, go off to the website, authorize it, come back, and then execute the payment. There's a flow in there. And optimizing these flows That's where this sort of mocking, playing becomes super critical to make sure all your identifiers flow through. So think about flow. Don't just think about one API at a time. How do they connect together? How do the identifiers relate? If you have hypermedia, how do your links play between those things and relay state? So I said earlier, we want everything to be resource-oriented as much as possible. Some things don't fit. Some things don't fit into that. You can't execute a payment as a CRUD operation. Doesn't make any sense. I mean, you could say that there's history of executions. In our case, we don't really expose it, so it's an RPC thing, and that's okay. But be careful. I talk a lot, too, about the Goldilocks principle of, is it too small or too big? I want to find that just right. Anybody read Goldilocks? Yeah? Okay, thank God. This was so hard in APAC. I did a whole 20-minute explanation, and I realized no one had ever read Goldilocks. Felt like I had to read it to them. So the idea here is tiny little resources, chattiness. And, that has its own pain. Big resources, they have a whole other kind of pain, which is namely that there's usually a lot of complexity and coupling between systems wrapped up in there. But it's interesting, I call this scalability as one of the things we check, but I actually don't necessarily mean it in the network and sort of system scaling perspective. But keep in mind also that beyond all those things, it's hard to actually define a bunch of tiny APIs because you end up with gobs and gobs of them. So your portfolio grows out of control. And if you have big, gigantic ones, it's really hard to add stuff to them because they're already so big and complicated, nobody wants to change them. So always try to feel out, and there's no perfect answer, right? It's finding the right fit, but usually it means taking some underlying data and simplifying it. That's usually kind of the gist of this. So obviously the G word in my job is the governance kind of piece. What I would say about this is automate every bit of it you can because it's horribly boring and nobody wants to sit and go through that, but it has to be done. That said, not all things can be automated. So things like word boundaries, if you can give me an excellent algorithm to do word boundaries, defining naming convention in resource names, please pass it on. But it's a hard problem. So some things you just have to go through and you have to look at it and you have to be really, really, really careful and write it down. Even if it's not a RFC style standards, at least write down patterns and guidance on what you expect people to do. Because if it's not written down, then you have an argument waiting. And every time somebody brings up something more than once that you're missing, add it to a backlog. We maintain a backlog for our standards that's always deep, but we always have stuff to work on in the lull to fill in all the blanks. So as part of all this, having a small team and a big company and gobs of APIs, we've developed 75% of our capabilities this year from a chaotic landscape into a organized portfolio of REST APIs. You cannot do that with a small team effectively. It's just not going to work. So the reality is there's a lot of awareness building that has to happen, and really this is the internal evangelism part of the job, is going around to offices with people face to face, finding the smart guys, right? Find the thought leaders that everybody looks up to and everybody's looking to for advice when they're building stuff. And honestly, it hasn't taken much convincing. I think everybody's been excited about, modernizing the platform. We're operating on good principles here, but getting them excited about why we have certain design decisions, going through the principles of what our standards are based around and what we're looking for in these sort of formal assessments that we provide people. Because once they understand what we're trying to avoid, all the problems that can crop up from these bad design patterns, they get excited about enforcing it and they become our local advocates. So we have an extended team in pretty much every development location now that operates with the goal of basically being the API designer for their given domains, office, organizations, whatever fits. So my hope is I work myself out of a job here with doing sort of design standard stuff, and it just becomes part of the fabric of the culture of how we do things. But it's real work, it's teaching work, and learning to teach and educate when you're doing this kind of platform stuff is a big part of it. So find a good teacher and ask them a lot of questions. That's what I'm learning. I jumped ahead there, didn't I? Oh yeah, so Sorry, I rearranged right before I did this. That was supposed to be there. That was eternal evangelism. Now I'm coming back here to the actual slide, which is listening a lot. So we do a lot of customer feedback sessions, and our customers most commonly are internal developers. So asking them, how is it hard to build APIs? What kind of tools do you need in your IDEs? What kind of support do you need from our frameworks that we use for all of building all of our stuff? What kind of tooling, instrumentation? What is it that you're missing? And within the design standards, within the way that we communicate how we want to build stuff, where are you lost? Where are you coming for design assessment and getting bashed for having a lousy design when you thought you were doing a good job? So we're always trying to kind of beef up all that information. So we've got tech writers that are working on our content on our development portals to make sure that there's a good developer experience for the guys building it, in addition to the guys consuming it. So we do customer interviews on both sides of that equation, at least every week or two, and with a different group each time. So yeah, like I said, go teach, go out, evangelize. And that's all I got. And since I started with hey, I'll finish with tuck.